Assalamualaikum and hi. We are from Mara Junior Science College Johor Bahru. My name is Kalika Darwisha.
And my name is Noralia.
My name is Amna Kaisara.
And my name is Nurkisina Khairi.
My name is Sher Adrin Batusha. So today we would like to introduce our project Hextar. Before we begin, let's start with a problem statement.
In the Form 2 KSSM science syllabus, the heat experiment primarily emphasized the role of color in determining the rate of heat absorption and emission. This experiment typically compares dark-colored surfaces, such as black, with light-colored surfaces, such as white, to demonstrate how color influences the ability of a surface to absorb and emit heat. However, this approach focuses solely on color and does not consider other critical surface properties, such as texture and material composition, which also significantly affect heat transfer. By broadening the scope of experiments to include these factors, students can gain a deeper understanding of the complex interplay between surfaces, characteristics, and heat transfer, providing a more holistic perspective on the principle of heat absorption and emission.
Then, let's take a look at the objective of our project. First, to investigate the heat absorption and radiation characteristic of different materials. This objective focuses on measuring and comparing the heat absorption and radiation rates of various materials under controlled conditions. Second, to develop a low-cost Arduino-based system for real-time temperature measurement and data logging. The aim here is to design and implement a cost-effective automated system using Arduino Uno infrared thermometers, Bluetooth modules, and LCD screen.
Number 3, to enhance students' understanding of thermal properties and clear misconceptions about heat absorption and radiation using hands-on Arduino-based experiments. This objective aims to provide students with a practical, interactive learning experience that deepens their understanding of heat absorption and radiation. Number 4, to strengthen students' critical thinking and problem-solving skills through data analysis and interpretation of heat absorption and radiation results. This objective focuses on encouraging students to actively engage in the scientific process by analyzing and interpreting experimental data.
This project is based on 3 out of 17 science development goals. First of all, SDG number 7, affordable and clean energy by promoting understanding of heat absorption and radiation, which is key to designing energy-efficient materials and systems. This knowledge can contribute to reducing energy consumptions in the buildings, appliances, industrial processes, advancing sustainable and modern energy solutions for all.
SDG number 9, Industry, Innovation and Infrastructure by fostering innovation through an Arduino-based system to explore thermal properties of materials. It promotes affordable and accessible data collection technologies, making it valuable for students, engineers, and researchers. By addressing real-world challenges in energy efficiency and material science, the project contributes to sustainable industrialization and resilient infrastructure development.
And finally, SDG number 12, responsible consumption and production by advancing understanding of energy-efficient materials and fostering sustainable design practices.
It encourages responsible resource use and has potential application across multiple industries, promoting environmental stewardship.
This project involved the design and implementation of the Hexagonal Thermal Absorption and Radiation Analysis Kit, Hextar, a device aimed at analyzing heat absorption and radiation properties of various surface types. The kit consists of multiple surface materials arranged in a hexagonal configuration, including white perspex, black perspex, plastic, metal plate, wood plate, and clear glass. A heat source is placed at the center of the hexagonal structure, and the structure are exposed to it. The system integrates modern technology for precise data collection and analysis.
The hexagonal assembly is placed on a rotating display, allowing each surface type to be systematically exposed to the heat source. The experiment is designed to explore the rate of heat absorption and radiation for each surface material, providing insights into how surface properties such as color, texture, and material composition affect thermal behavior.
Now, let's take a look at the methodology of this experiment. Preparation of surfaces. Different surfaces were prepared to test their thermal absorption and radiation properties. The surfaces included a white painted perspex, black painted metal plate, wooden plate, clear glass, and a plastic surface. These materials were chosen to observe how different colors and materials interact with heat. Next, setup of the experiment. The experiment utilized a rotating display to hold and expose all surfaces uniformly to a heat or light source. An infrared thermometer was used to measure the temperature of each surface, capturing values between negative 70 degrees Celsius to 368 degrees Celsius. The system was powered by a connected power supply with an Arduino unit controlling and recording data.
Next, data collection tools. Key tools included the infrared thermometer for temperature measurement, a screen display for real-time output, and sensors linked to the Arduino for accurate data collection. Additionally, Bluetooth communication allowed for wireless transfer of recorded data for further analysis. As you can see, this is a video of experimental procedures. Next, for data analysis of our project, the recorded temperatures were compared to identify differences in heat absorption and radiation among the materials. Patterns were analyzed to determine the surface absorbed or emitted more heat. Results were linked to scientific principles, highlighting the relationship between surface properties, color, and heat transfer.
The Hexagonal Thermal Absorption and Radiation Kit is a practical and innovative educational tool designed to simplify complex thermodynamic concepts for grade 7 and 8 students. By integrating diverse materials, an Arduino-based data collection system, and step-by-step visual aids, the project addresses cognitive challenges and enhances an understanding of heat absorption and radiation. Furthermore, the kit aligns with global goals such as SDG 7, SDG 9, and SDG 12, promoting energy efficiency, innovation, and sustainability. This project not only fosters academic curiosity, but also inspires responsible practices in energy consumption and material design, making it a valuable contribution to education and sustainable development. That is all from us, and
Goodbye!